Let's look at an issue. So before that, let's frame the question. Are eddy viscosity models realizable? That means physical. So we'll take an example and see what it looks like. So one issue is coming from Boussinesq itself. Okay, that was the origin. The closure for your Reynolds stresses came from Boussinesq. So we look at a limitation of Boussinesq. This issue is also called irrotational strain issue. So we'll see what happens here. So if you recall Boussinesq, it is essentially ui prime uj prime average minus of this is equal to 2 nu t Sij bar minus 2/3 k delta ij. This is the turbulence closure using Boussinesq. Now I would like to take one of the normal stresses, because I already said normal stresses must stay positive. It's a square term. So I would like to take one normal stress. Let's say let I equal to j equal to 1. That will give me u1 prime average. So this must stay positive. So this I can write it as 2/3 k delta 1 of course, which is 1 minus 2 nu t S11 average. Okay. So what does this give me actually here? This gives me 2/3 k minus 2 nu t. This is nothing but half of dou u1 bar by dou x1 plus dou u1 bar by dou x1, dou I bar by dou xj plus dou uj bar by dou xi. I and j both are 1. So this essentially becomes, so this is equal to your u1 prime is therefore equal to 2/3 k minus 2 nu t dou u1 bar by dou x1. Now, is there a chance that this Reynolds stresses, this particular Reynolds stress go negative? There is a chance here, right? So it must always stay positive, then only it is realizable or physical. Now according to Boussinesq, there is a chance u1 prime bar can become negative. And when does that happen? When this particular value takes large value. If this becomes a very large value, that means large strain, irrotational strain, right? It's a dou u1 bar by dou x1 is an irrotational strain, it's not a rotational part, volumetric strain. So large irrotational strain. So turbulent is vertical flow. One of the definition I told you, turbulence is characterized by 3-dimensional vorticity fluctuations. So it is rotation dominant flow, not this volumetric strain. Okay, but here we have a situation where there can be a large irrotational strain, that is dou u1 bar by dou x1 becoming very large. If this happens, then you are, okay, you can say for a large irrotational strain, this u1 prime can become negative, right? Normal stress becoming negative according to Boussinesq in a given flow where such a thing can exist, where you have a large irrotational strain, and therefore this is unrealizable or unphysical, right? So by default the model can give wrong result. Similarly, this can happen for the other two normal stresses, u2 prime average, u3 prime average. Okay, so this is one situation where you can have a large irrotational strain, large positive value here, of course, there is large positive value, right? This can lead to normal stress going negative. We can also have an example for this where something like this can happen, and which is commonly occurring in many flows. If I take an example, I can consider another situation or an example here. Unrealizable flow example, or I can say in a stagnation zone. So this kind of a flow you would have seen or will encounter, that is flow, let us say you have a flow over a bluff body, let us say I have a bluff body and then you have flow over it. So this is your stagnation zone, right, the stagnation point here. Such a type of a flow, or you can have get a region like this, let us say you have a plate and then you have flow impingement. Flow impinging on a plate, these kind of situations can occur, right? So we can have the coordinate system for this as, let us say, x1, x2, this is x1, x2, same coordinate system. Again you have a stagnation zone here. So around that you will have a locally a stagnation zone, flow is stagnating. So in that kind of a situation, what will happen in this stagnation zone? What will happen to the irrotational strain? This dou u1 bar, so in such stagnation zones, what would happen to let us say dou u1 bar by dou x1, what will this be? The u1 bar is 0 on the wall here, nearly 0 around it, and little bit away from it, it is very large. So this is large negative value, right? So dou u1 bar here, dou u1 bar by dou x1 is a large negative value. It is large negative value, irrotational again. So if I have this a very negative dou u1 bar by dou x1, so let us look at the Boussinesq again. So I have ui prime average is equal to the same formula, right? So I have this 2/3 k minus 2/3 k delta ij minus 2 nu t Sij bar. So if here I take I equal to j equal to 2 now. Let's see what happens to that. I equal to j equal to 2 gives me u2 prime average is 2/3 k minus 2 nu t, okay, minus 2 nu t dou u2 bar by dou x2, just like the equation that we have seen here, 2/3 k minus 2 nu t dou u1 bar by dou x1 above. This will be one equation, let's say. Similarly, I have I equal to j equal to 3. I get u3 prime average is 2/3 k minus 2 nu t dou u3 bar by dou x3. Now if I add these two, okay, adding 1 and 2, so equation 1 plus 2 will give me u2 prime average plus u3 prime average equal to 4/3 k minus 2 nu t dou u2 bar by dou x2 plus dou u3 bar by dou x3. Now I can use continuity here, right? So this gives me 4/3 k minus 2 nu t of minus dou u1 bar by dou x1 using continuity here. Okay, substituting this part by minus dou u1 bar by dou x1. Okay, so the formula here becomes 4/3 k plus 2 nu t dou u1 bar by dou x1. But what is dou u1 bar by dou x1? Here, large negative value, extremely large negative value. So dou u1 bar by dou x1 is large negative. So this becomes very large negative. So this becomes 4/3 k. K is always positive here. Okay. So note, k is positive. K is positive and your dou u1 bar by dou x1 is large negative. Sorry, not equal to 0. It's just is large negative value, right? Large negative value dou u1 bar by dou x1. So that means this is positive and this is large negative, making the entire equation, that is sum of these two, as negative, right? So this can imply that this implies u2 prime average plus u3 prime average, the sum can go negative. Sum is going negative. Okay, I'm looking into the total sum. This plus this is equal to the right part. K becoming positive, dou u1 bar by dou x1 is extremely large negative value, and therefore the sum of the two normal stresses becoming negative. So now this does not mean that both are negative. There is a good chance that both stresses can be negative, or one is very negative compared to the other one. Either way, it is unrealizable or unphysical, because these two has to be positive, correct? So this means that one of them must be very large negative, or I can write in the next slide. So this means either u2 prime average and u3 prime average, or I can say both, not both are negative, or one of them is very large negative value. Either way, it is unphysical. It is unphysical since normal stresses must stay positive. Okay, so we have seen an example where it can go completely unphysical. Your eddy-viscosity model by default, whichever model you are using, will give you, because you are using fundamentally Boussinesq, then you are deciding for eddy viscosity, you are deciding k epsilon, k omega SST, so many variations, right? Different types of models, 1, 2, 3, 4 equation models, but this is an issue with the Boussinesq itself. So this will lead to unphysical, unrealizable behavior. We will see how we can fix this in the next class, as well as look into other problems you will get from Boussinesq, okay, and also the solutions for that.